So here we need to find the limiting value of the given function when x approaches 1. So we begin by first substituting the value of x. So we have 1 over 1 plus 1 minus 2 minus 1 over 1 minus 1. So that gives us 1 over 0 minus 1 over 0, which is an indeterminate form of infinity minus infinity. However, we need it to be in the form of 0 over 0. So what we'll do, we're going to combine the two rational functions. So let us begin by first factorizing the denominator of the first rational function. So we can split the term, and that is going to give us x minus 1 times x plus 2. So I've already covered how to factorize a quadratic polynomial by splitting the middle term. So that's covered in the previous sections. I worked out problem number 1 and worked out problem number 2. So you can go and check it out there, which is equal minus x divided by, now x cubed minus 1 is an identity, so that can be expanded as x minus 1 times x squared plus x plus 1. Now we're going to factor out 1 over x minus 1. That is common in both the two rational functions, so that leaves us with 1 over x plus 2 minus x divided by x squared plus x plus 1. Now we are going to combine these two rational functions, so that will be limit x going to 1 over x minus 1 times, so we are going to perform the butterfly method. So here we are multiplying the two of the denominators, and then we are going to cross multiply the numerator and the numerator of the first rational function with the denominator of the second rational function. So that will give us x squared plus x plus 1. Similarly, we multiply the diagonals x plus 2 and x, so that will give us negative x times x is x squared minus 2x. So x squared and x squared gets cancelled out. Limit x going to 1 over x minus 1, we have negative x plus 1 divided by x plus 2 times x squared plus x plus 1. Now this negative x plus 1, what we can do, we can rewrite it as limit x going to 1. So we're going to take negative 1 as the common factor, so we have negative times x minus 1 divided by x minus 1 times x plus 2 times x squared plus x plus 1. Now when we substitute the value of x, so we will get the indeterminate form 0 over 0. So that is happening because x minus 1 is the common factor. So this is what we need to get rid of from both the numerator and the denominator. So that will leave us with limit x going to 1. We have negative 1 over x plus 2 times x squared plus x plus 1. Now we are going to substitute the value of x. So we have negative 1 over, so 1 plus 2 is going to be 3. Multiply to 1 plus 1 plus 1, which is 3. So that gives us negative 1 over 9. So this is going to be the limiting value of the given function when x approaches 1. So we need to determine the limiting value of the given function when x approaches 1. So let us begin by first substituting the value of x. So we have 1 over 2 minus 2 minus 4 divided by 2 cubed plus 8 minus 2 times 2 squared will be 4. So we have 2 times 4, which is 8. So we have 1 over 0 minus 4 over 0. Now this is giving us an indeterminate form of infinity minus infinity. However, we need an indeterminate form of 0 over 0. So that means we have to do some algebraic manipulation here. So what we're going to do, we are going to factorize the denominator of the second rational function. So we have 1 over x minus 2 minus 4 divided by, so what we're going to do, we're going to take x squared as the common factor, so that leaves us with x minus 2. Then we are going to factor out 1 over x minus 2. So we have 1 over x minus 2 multiplied 1 minus 4 over x squared, which will be equals to limit x going to 2, 1 over x minus 2 times x squared minus 4 divided by x squared, which will be equals to limit x going to 2, 1 over x minus 2 times x squared minus 4. Now this is an identity, which is x squared minus 2 squared, so this can be rewritten as x minus 2 times x plus 2 divided by x squared. Now when we substitute the value of x with 2, that gives us 1 over 2 minus 2 times 2 minus 2. We have 2 plus 2 divided by 4. So this is going to be an indeterminate form of 0 over 0. So this is happening because x minus 2 is a common factor in both the numerator and the denominator. So let's get rid of that, and that gives us x going to 2. So we have x minus 2, and this x minus 2 will get cancelled out with the x minus 2. So we are left with x plus 2 in the numerator divided by x squared in the denominator. So now we are going to substitute the value of x. So we have 4 over 4, so which is equals to 1. So this is going to be the limiting value of the given function when x approaches 2. So here we have to determine the limiting value of the given function when x approaches 3. So we substitute the value of x, 3, so that gives us 1 over 3 minus 3 minus of 3 divided by 3 square minus 9, which is equals to 1 over 0 minus 3. So 3 squared will be 9. So we have 9 minus 9, which is 0, and that is giving an infinity minus infinity, which is an indeterminate form, but we need it in the 0 over 0 form. So let us do that. So we are going to factorize the denominator of the second rational function. So we have 1 over x minus 3 minus 3. So what we're going to do, we're going to take x as the common factor, so that leaves us with x minus 3. Now we're going to pull out the 1 over x minus 3, so that will be 1 over x minus 3 times 1 minus 3 over x. Now we're going to combine this to fraction, so we have limit x going to 3, 1 over x minus 3 times x minus 3 over x. Now when we substitute the value of x, that is going to give us 0 over 0, which is the indeterminate form that we are looking for. Now this indeterminate form 0 over 0 is occurring because we have x minus 3 as the common factor in both the numerator and the denominator. So let's get rid of it and rewrite the rational function as 1 over x. So now we substitute the value of x, so that gives us 1 over 3, which is going to be the limiting value. This is quite similar to the previous problem when we substitute the value of x by 1, so we get infinity minus infinity, which is an indeterminate form. So we are going to do a little bit of algebraic manipulation. So where we have 1 over x minus 1 minus 2, so x squared minus 1 can be rewritten as the product of x minus 1 and x plus 1. Now we are going to pull out the x minus 1 from the denominator of each of the rational function. So we have 1 over x minus 1 times 1 minus 2 over x plus 1. Now we are going to combine 1 minus 2 over x plus 1. So that will give us 1 over x minus 1. So we have x plus 1 as the common denominator. That gives us x plus 1 minus 2, which will be limit x going to 1 over x minus 1 times x minus 1 over x plus 1. Now when you substitute the value of x by 1, that will give us 0 over 0 times 1, which is in the form of 0 over 0. This is the indeterminate form that we're looking out for. Now what we're going to do, now we're going to factor out x minus 1 from both the numerator and the denominator, because that was the factor which was giving us a 0 over 0 indeterminate form. Now we substitute the value of x, so that gives us a limiting value of half.